Okay, we're ready to solve this fractional equation. Notice it's on the upper left of your screen. We all dislike fractions, but there's some good news. There's a way to remove all the denominators to create an equation that has no fractions in it. It takes a couple of steps, but it is worth your while to learn this process so you can avoid dealing with fractions. We know they're annoying. We all agree that they are. All right, so let's, actually there are two methods that I can show you, but let's deal with method one first. All right, remember our goal is to remove the fractions. Before we can remove them though, we have to make all the denominators the same to help us remove them in the next following step. All right, let me just start rewriting each fraction with the same denominator. Well, to get the same denominator, we need the lowest common denominator or the LCD for each of these fractions. So the LCD for, let me rewrite the whole problem so I can clearly demonstrate. So it's 5x over 6 plus 7/12 equals 3/4. Okay, so we're looking for a number, or the LCD, that 6, 12, and 4 all go into. Turns out to be that 12 can be divided by 6 evenly, 12 goes into itself equally, of course 1, and 4 can be divided into 12 equally, or 3 times. Okay, so that means now we know that we want to make the denominator of each fraction the same. So let's see how we do that. All right, I'm going to rewrite the fraction again, or all three fractions, that is. Okay, well, we want to rewrite each of these fractions as they call them equivalent fractions with a like denominator. Well, since the denominator that we desire is 12, your goal is to make the denominator 12 by simply using simple arithmetic. So we have 6 times 2, that'll give us 12. But in a fraction, if you want to maintain its equivalency, we have to multiply the numerator also by that same quantity of 2. And what we're actually doing is multiplying by 2 over 2, which is really 1. And we call this a quantity of 1. So quantities of 1 could be 2 over 2, could be 1 over 1, could be 3 over 3, etc. So we're going to use all quantities of 1 to maintain this, we call it equivalent, to produce an equivalent fraction. All right, we're on to the next one now, next fraction. Well, we already have a 12, but for demonstration purposes, I'm just going to put a 1, because 1 over 1 is 1, and the denominators now so far are 12. Let's look at the last fraction on the right. We have to multiply by, you got it, 3. And the top by 3, and there's your quantity of 1. I'm going to now rewrite each fraction in the equation with the same denominator. So we wind up with 10/12 x. I'm going to put x in the numerator so there's no confusion about where the x belongs. It belongs on the top. Plus 7/12 equals 9/12. Okay. Well, here's the trick. Here's the trick to remove all your denominators. And let me just make a note on the side to help you understand why we can do this. It turns out to be, if you're given, let me give you an example. If you're given 7 plus 3 equals 10. Well, we know this is a true statement. My question to you is there a number that I can multiply both sides to maintain the equality? So I'm going to pick any number off the top of my hat. I'm going to multiply by, I don't know, 5. So I'm going to multiply this side by 5, and I have to then multiply the other side of the equation by 5. And we know that this will maintain the equality. So let's actually do the math. And so we get now 5 times 10. Does that equal, put a big question mark, 10 times 5? And of course, 50 equals 50. So we know that we can multiply both sides of an equation by the same number, and the equality is still true, or it's true. All right, so let's take an example now. Oh, let's see. Let's take 3/8 plus 2/8 equals, well, what does that equal? It equals 3 plus 2 over 8. Agree? Okay, now, if I want to remove the denominators, it makes sense to me to multiply by a number that will cancel the denominator. Well, it appears to be, since all the denominators are the same, I'm going to multiply by 8. And if you want to be very clear, it's 8 over 1. So I'm multiplying both sides of the equation by 8 over 1. Well, when you're multiplying fractions, you are allowed to cross-cancel, or cross-reduce as they call it. And so if we do that, this becomes a 1, and this becomes a 1. Remember, we're distributing. So when you're distributing, you have to multiply both fractions by 8 over 1. So this now crosses out, and again, this is 8 over 1, this cancels out, and then finally on the last case, this cancels out to 1. Now notice, there are 1s in the denominator, which is what we desire. So now let's rewrite the equation and see if it's still true without any denominators except for that 1, which we don't really need to write. So the 8's canceled out here, and we get 3 plus 2. Does that equal 3 plus 2? Absolutely. So if you want to remove like denominators, if each term in the equation has the same denominator, you could multiply both sides of the equation by the LCD. In this case, it was 8, and then you wind up with a very pretty equation with no fractions. All right, let's go back now to our problem up here on the left. It makes sense, I hope you see that if I want to cancel all the 12's in the denominator, it makes sense to multiply both sides of the equation by 12. I'm going to rewrite the whole equation over so I don't skip any steps. So I wind up with, you know what, let me put a 1 under here to make it clear. So now we get 12 over 1 and distribute times 10x over 12. Distribute again now with the 7/2, put the plus in. 12 over 1 times 7 over 12 equals 9/12 times 12 over 1. All right, the good news is when you're multiplying, you can cross-reduce, and I'm going to put the 1's in after I cancel. Cancel here again, and cancel here one more time. Let's see what the result is. Now that there are 1's in the denominator, we can simply write 10x plus 7 equals 9. Isn't that pretty? Okay, we have now an equation with no more fractions, and we can simply solve. So let's do that. -7 from both sides. I'm going to transpose the 7. I'm left with 10x equals 2. Now, since this is a product, we're going to divide by 10 on both sides and then reduce the fraction. So x turns out to be 1/5. All right, so this is a very nice method to reduce, or I'm sorry, to remove denominators from the equation in all the terms. Okay, let's try one more example. Okay, here we go. Why don't you try pausing the video, try this example, and come back and see if you are indeed correct. All right, I'll see you in a minute. Okay, so the first step is to find the LCD for each fraction. So the LCD for 18, 6, and 3 is 18. All right, I'm going to rewrite the equation so we can still see what the original was. And I get 5 over 18 minus x over 6 equals 2/3. All right, again, now we need to find a quantity of 1 that we're going to multiply by each fraction to change the denominator to 18 for each fraction. Okay, just for demonstration purposes, I'm going to multiply by 1 over 1. In the next case, I'm going to multiply by 3 over 3. And in the last case, I'm going to multiply by 6 over 6. Now remember, multiplying by a quantity of 1 doesn't change the value. It only rewrites it as an equivalent fraction. Okay, now we're ready to rewrite each fraction. So 1 times 5 is 5 over 18 minus 3x over 18 equals 12 over 18. All right, what was that nice trick that I had shown you previously? We can multiply both sides of this equation by 18 over 1 on both sides, and then distribute, and then cancel. So, for demonstration purposes, I'm going to rewrite 18 over 1 times 5 over 18. You can skip this step if you're familiar with this process, but let me do this now. So it's 18 over 1 times 3x over 18 equals 12 over 18 times 18 over 1. Okay. Now we know that cross-canceling will allow us to do this, and there's your 1 in the denominator. Notice it's set up beautifully for you to do this. And let's see what we get. Well, there's 1s in all the denominators, so now we just get 5 minus 3x equals 12. Perfect. All right, let's transpose the 5. We're going to minus 5 from both sides. And don't forget to bring down the negative 3x equals 7. To solve this equation, we need to divide both sides by a negative 3. And the proper way to write a negative fraction is to put the negative on the side, and that tells you that the fraction is negative. And the answer is x equals negative 7/3. Now, I promised to show you how to solve this problem in another way or another method, and it's very convenient. Okay, method 2 is on the right screen. We know that the LCD is 18. So right from the beginning, step number 1, why not just multiply both sides of the equation by 18? And we know that if we multiply by 18 to each term, that the denominators will cancel at this point instead of having to make them all the same. Now, it'll be your choice if you want to skip that initial step and go straight to multiplying both sides by the LCD. So in this case, this is what I did. I distributed, and I wound up with 18 times 5/8, 18 times negative x over 6, and then multiplied 2/3 times 18. And I rewrote the problem right here. I canceled, if you notice. The 18s go out to 1. Here, 6 goes into 6 one time, into 18 3. And on the right side of the equation, 3 goes into 3 once, and 3 goes into 18 6 times. Let's see what's left. Once the 18s are canceled, you can clearly see that what's left is 5 here, a negative 3x here, and a 12 here, and it looks exactly like this problem here, and we saved ourselves a step. All right, again, choose which method you like, the first method or method 2. All right, for the next example on your screen, I would pause the video, come back, and check the solution. I'll write it out as soon as you come back. Okay, so notice in the steps, the first step, we multiplied each term of the equation by 24, canceled each denominator, and the denominators are now 1, rewrote the equation, and I'm running out of my time. So I wind up with 28x minus 9 equals 12, and follow the steps. X will equal 3/7.